back to Artificiality. Today we're here to talk about the big topic of the day, DeepSeek, and the new release that the company put out, along with all the research and the chatter and everything else that's going on. So I'm going to run you through kind of how to think about what's been released, and then we're going to talk a little bit about why it matters, what's interesting, have a bit of a chat about it. So quickly. What's new is DeepSeek has created a couple of key breakthroughs in terms of how LLM systems are trained and how they're run, or the inference time, how it's in real world use, making it cheaper, faster, more efficient. And this has sent, I think it's fair to say, shockwaves through the industry. People are chatting about it all over.
I heard someone say on the AI Richter scale, 8.
8. Ooh, that's interesting. I love how you make it into a...
It wasn't me that did that, but it did catch my eye, or attention. Yeah.
Yes, it's rattled stock prices of companies that have been recognized for AI leadership, in particular NVIDIA, even down to the power companies that are derivative plays. It's made a lot of noise. So let's figure out what's going on. So there's sort of 5 things that I'm going to talk about in terms of the sort of why this matters, what they did. The first 2 are really sort of focused in on training stuff. The first is that they are using a technique that's called FP8, which is working with less precise numbers, is basically the way to think of it. So if you think about, if you took a number like 10.857.643, and you rounded it to 10.86, it probably wouldn't make much of a difference in a lot of different cases. And in some ways, that's like the basic premise of something that they've done. Allows you to cut the memory and the computation significantly down. The idea of rounding numbers seems to be effective.
So we won't be using it for weather forecasting, is what you're saying?
Maybe not.
Yeah.
Although when you do forecast weather, I assume you round to the actual temperature.
I'm just making a play on the fact that was how chaos theory started, was this rounding error issue.
I forgot
the butterfly thing. You know.
Okay. Second is something that's quite important, and we'll circle back to this right at the end, is the idea of what's called distillation. So this means that they trained their model by learning from other AIs. So the traditional approach that generally is used by OpenAI and Google and Anthropic and Meta, etc., is that they're training on this, massive amounts of data. Now, there's always been some amount of question about how much any one company is learning from some other company's models. Basically, by pinging it lots of times, you can sort of back engineer, is the way to say it. It's not technically totally correct, but that's sort of the idea, is that you can get a sense of what's going on. And that it appears that DeepSeek has done a lot more of that. So
the easiest way to think about distillation is that a teacher teaches the student, and the student knows a summary of what the teacher knows.
Yeah, that's pretty good. And so it means that they're able to get to much closer to the current state-of-the-art class model faster, and doing it basically by kind of copying-ish,
Very loosely.
Very loosely. I'm being very loose. I'm trying to be very plain English about all of this. So if there's fault in the way I'm trying to communicate it, it's in that gap between the very technical and the more easily understood English language. Third thing is a trial and error learning. This was important in the R1 model. Now, again, they released a whole bunch of things. This morning, before we recorded this, I saw that they open sourced an image model. So a lot going on from these guys. So an R1 model is that they found a new technique, or implemented a technique for trial and error learning. Now, most of these models, when you're getting to reasoning, have a lot of human feedback in the model. And in this process, though, they let the machine do it. So they showed them a whole bunch of problems, gave them some sort of basic techniques to solve these problems, then told the models to go see what they could do, and they gave them sort of an incentive to show their work and then go back and relearn again.
So another triumph of
reinforcement learning.
And the bitter lesson.
Yes, and so it is, and it has I like this because you and I talk a lot about aha moments, that they talk about the fact that the model had aha moments where it discovered a better way to solve the problems. Part of this also was interesting, is that part of what made this successful for them is they found a way to get the model to basically polish and explain the thinking more clearly. So at first, in the paper they talk about how it was like it would come out and it wasn't easy to understand, but they had to sort of improve its communication capabilities for the model to learn from it itself. So those are 3 things. I think I said 5 at the beginning, and then there's actually 6. Sorry.
So you need an AI to help you.
Need an AI to do it.
Yeah.
So next one is sort of an idea of smart team management. Now we've had mixture of expert models. So the idea of a mixture of expert model just basically is you either have a lot of these LLMs started off as one massive model, and every time you wanted to access it, you had to access the entire model. That means a lot of compute power because you have to turn the whole thing on basically and run the whole thing. Multiple companies have done this mixture of experts where it cuts the model down into smaller sizes that have particular specializations, and you only activate certain portions of the model at a time. Now, there's something going on in here that is that they figured out essentially a better management technique. So in a traditional model, they have an expert and they send a task to the expert, and then they have a method of sort of pushing work to all the other experts and try and say, you help out too, is kind of the way to think of it. But those you help out too people those experts are kind of generalists. They're not really necessarily the best ones. The interesting part about what has happened here is that they seem to have a better sort of project manager, if you will, that has better idea of which experts would be sort of best. And so they pick a series of those and run the projects, the tasks through them. So they're getting better performance out of that and better results. So there's something really interesting about that is important. 5th one is something called multi-head latent attention, MLA. This is really intriguing to me personally. I like it a lot. Is in terms of trying to dig in and understand it, is they've created a technique for essentially compressing data. So instead of taking everything that's in the model, everything that's in the context, keeping all of that in memory, which uses up a lot of memory on the chip, they've been able to figure out how to compress that down and then only decompress what's required for the actual task. And that's something that honestly I still need to better understanding of how they figure out that threshold. But it's pretty interesting. It's a bit like image compression, but more like lossy image compression, because you don't actually recompress back to a full image or back to the full data. That seems to have had a very significant impact on the compute cost and the memory requirements overall. The last one is that they've got this sort of model of looking ahead, whereas traditional AI predicts 1 word at a time or reads 1 word at a time. These are actually going 2 words ahead at once. And so it's able to basically just run faster and cheaper. So that's my rundown and my best attempt of explaining what is actually really quite technically complicated quickly and in plain English, how to do.
So a couple of questions, because I think there's a few things that are really interesting about this whole thing. One is that constraints are the things that, we constrain things, you drive transformational innovation, if you like.
Yeah.
Necessity is the mother of invention. How does it apply here? Okay, so there is a question about what kind of chips they ran this on. There's some theories based on some non-participants, as far as I can tell, sourcing how many NVIDIA chips of what kind of NVIDIA chips they actually have. There's a lot of ideas. It's hard to know, to be honest, how many chips they ran. They do describe some of that in their paper, but then there's a whole bunch of other questions, because the paper that it was really focused on is on their sort of last training run, so it's not everything that built up to it. But we do know that they have a constrained number of chips. We know they don't have at least as many as many as they want to have of the latest NVIDIA chips. And so this is in some ways just as you say, necessity was to try and figure out how to do this under memory constraints. And so they invented a whole bunch of techniques to figure out how to get around those constraints. So the other thing is cost.
Yeah.
Where might they maybe understating cost, whereas everyone else has been overstating, and what are the incentives there?
Yeah. So the training cost numbers that you'll hear out there is that this cost them $6 million to train. In the paper, it's clear that that's just their final training run.
So there's nothing, we don't know what the cost was to build to that point, and so that's kind of hard to know. It gets frequently compared against a $100 million number for a big model, state-of-the-art, open AI, so forth. Again, we don't have a great disclosure on exactly what's in those numbers either. It's either private companies like OpenAI and Anthropic that don't disclose, or they're big public companies like Google or Microsoft and Meta that don't actually give out those numbers in particular. I also wonder if anybody's going to estimate anything. DeepSeek is going to underestimate their numbers to show how competitive they can be with a small amount of money, and basically become the ultimate thorn in the big tech side. And if anything, the big tech companies are going to overestimate how much it costs because it creates an emotional, if not like true financial barrier, right? If it's going to cost $100 million to train a model, why would any venture capitalist fund a company that's going to compete with these big companies now? Because the roadmap to go from starting point to actually raising that amount of capital is just is prohibitive, or at least really difficult.
This goes beyond just open source, right?
Yes.
And it sort of makes this a much more nuanced conversation. Before I get to the next question, what are the other incentives that this young upstart might have that people haven't talked about in your mind at the moment?
Yeah, I do wonder about the fact that it's a spinoff from a hedge fund. And having spent enough of my life with hedge funds, there's always something below the surface. So first of all, not totally surprising to me that this is something that's spun out of a hedge fund. The hedge fund industry has been using these kinds of techniques for a very long time. They're wicked smart. They're really good at operating under constraints. They're always looking for an edge in a way that actually is completely driven by spend less and make more. So it got sort of the right mindset. I do wonder about
Don't they just want to make money?
They want to make money.
So how is this playing into that?
Well, that's the interesting part. So they put this out, and the inference costs are tiny in comparison to everybody else. So they're not charging as much for all of this. So either their costs are really, really low, or they're at the moment selling their inference for some sort of reduced margin, which could make sense if they're taking the play that they just want to have data. And that's what they're trying to hoover up is data. It could be that they have some other play at hand. I would love to know what DeepSeek's hedge fund parents' positions are in NVIDIA and all the other related stocks. Because
are you saying that they might have shorted?
I don't want to accuse anyone of
just
such
saying
a
it would
thing.
be a plausible.
I'm saying it would be one of the all-time greatest short selling stories I'd ever heard. That someone took a major short position in some of the most hyped stocks. Not that NVIDIA isn't. I'm just saying that there's a lot of momentum in this space. So I'm not trying to ding NVIDIA in that direct way, but there's a lot of momentum. And so what do? You have to create a counter narrative to momentum, and then once that momentum goes, it goes, and the stocks will fall. This would be an ideal way of actually taking the air out of the NVIDIA stock, because you're showing that somebody could do this for a fraction of the cost without their latest chips. So suddenly that deflates. And it's the ultimate time of the year. Everybody just had a big run in those stocks all of last year. You hold it through the end of the year so that whatever fund manager is holding NVIDIA counts that up and gets their bonus based on it. Turn around to January, if everything falls out, you sell. And you take a new position that you hope to, sort of build on a momentum to make your money for, 2025, if not even just for the quarter. But, so plenty of people take some profits, take some money off the table because this got deflated. That's a great play if you can find a way to knock down the stock story. And what an intriguing way of doing it by, putting out a competitive model.
Can't wait for the movie.
Yeah.
So
By the way, if I'm right, I want the movie rights.
Yeah, good luck with
I
that.
want to be in it.
We might just be making it here. Well, I tell you what, we'll make it in there, open source.
We'll make it, exactly. Yeah.
So if I just was on the frontier of this and had invested just years of my life in building this.
Yeah.
One, I got to feel a little bit weird right now.
Yeah.
But two, I'd be worried about if the whole thing is that it's all distillation, you can do funky stuff there. Why would I what's my dilemma is what's publicly available now.
Yeah, I
I think this is actually one of the most interesting parts of it. I mean, apart from the speculation about their shorting the stocks, which has been a fun topic of discussion today, I think it's really interesting to think about if what we think has happened and occurred, right? So there's a lot of stuff that we don't really know, but based on the premise that a lot of how quickly they were able to do this and how cheaply they were able to train this model is based on distillation and essentially going and hoovering up all of what's inside of the other models. Not really hoovering up, but basically paying and learning from those models. If I'm
Creating the student.
Yep. If I'm sitting at any of the other model companies and I'm thinking about my next generation model. So the premise of distillation is really fascinating because it basically says that it's easy to be a fast follower. Is that you come out with a brand new model and then somebody else can come in and quickly and much more cheaply get close to or at the same level of performance as that model.
Well, and there's an accelerating aspect to that because the machines are teaching themselves as well.
So if you
there's a real flywheel.
Yes, there is. So if you take that as an idea and you say, okay, well then what is my incentive for putting out my next generation model? I don't have any competitive advantage. So OpenAI comes out and wants to put out 5.0. Well, that'll get copied through distillation really quickly too. So what's the advantage of putting it out at all? Because you don't have any advantage unless what you do is that you say, okay, the nature of our business is going to change. And this whole idea of being a foundation model company, that you put out the model, you make it easily accessible, that you make it accessible through an API that people can ping and actually interrogate, is you actually have to build it within an application that has more opaqueness to the actual operations of the model. Somehow it makes it harder for people to actually get in there and actually distill the model to be able to be extracted and used in a fast-following development. Now, I don't really know what that would mean, to be honest, and from a technical perspective, but I can understand the product strategy that you'd stop and say, hold on, what we're doing now, we're plowing all of this money in because you need that. As far as we know, these techniques don't appear to be the ones that are going to move us to the next generation model, right? They're more about techniques. Some of these techniques will make it easier. Some of the self-learning stuff is going to make it easier. Some of those things are going to make it faster and cheaper. But there's gaps in that the distillation doesn't allow you to go any further. And we may still need those large-scale training models, large-scale data centers to train models to get to that next generation. But then DeepSeek will come along and distill it and copy it quickly. So what's that? The other major thing that I think is going on for big companies is that if their techniques prove to continue to keep the inference cost low, it'll do a couple things. One, it'll mean that whatever your current run rate is of charging people through your API for inferences, if you implement these, your revenue is going to plummet because you're going to have to be selling it for much cheaper. Now, that's good for your customers, it'll make it a lot cheaper. There's both a potential softening in there, right? Because everything gets cheaper and that gets to be problematic. But the upside is that it could become so much cheaper to run these models that we'll be just using them much more. And that's been kind of this breakthrough that you and I have been talking about for a year or two, is this question of memory, is that memory is the sort of one of the, if not the key gate that you have to get through. We need the models to be able to remember more, obviously, and have more data. But the real thing is they have to remember more about us. They have to have a context about us to make the answers useful, and without us having to input it every time, and without it having to cost so much. So we've seen more memory coming in through ChatGPT's memory function, or the way that Anthropic can organize things in a project, and so you can put more stuff into there. Google's got this huge memory, but it costs a lot today to use that memory, and so you're always limited in terms of the number of prompts. You can't just be chatting with it all day. It just is cost prohibitive. This change in inference cost may indicate that we've seen some sort of breakthrough, and hopefully many more, because it's still not cheap enough to be running all day. But that's a big change. Anyway, all right, well, there you go. That's our technical discussion for today.
Well, it wasn't really technical. It was more about like the dynamics on the market.
Yeah.
So any kind of high level predictions about what this might drive it feels like it's gonna yet another sort of pulling apart to a very open, vibrant, open source community. I mean, so Hugging Face has put up other ways of, you know, adding your own RL. On the closed models, it really has to have some sort of product abstraction layer that does two things now: better user experience, but also somehow protects the model. I'm not sure what that looks like, but you can imagine the concept of it. And it's if these costs really are this low, I think it's pretty reasonable to suggest that your incentives, what you suggested, is that these you know, showing slightly misleading numbers, but nevertheless the story's probably pretty true.
Yeah.
Is if we get so much cheap AI and it's just so abundant, then well, it's good to see that the cost of AI dropped to nothing before the cost of humans dropped to nothing. At least we've got that order right?
Yes.
But it's certainly, you can start to see the sort of accelerated takeoff of the use of it, as long as it becomes more and more useful.
Yeah. I think I'd say that
we also haven't seen, it's only been out for a little while,
yeah.
and people game benchmarks all over the place.
Sure.
And conceptually, there's got to be something. If you're using a mixture of experts where the experts aren't as expert, or you're using and you've somehow, you know, compressed and then reinflated the knowledge, the learning of the overall data manifold has got to break somewhere. So there's still many more days ahead of us as people really pull and push on this to see just how good the performance is. It's so early to even assess that.
Yeah, so I think that there's probably three big picture things. One is, I think that this indicates that the race to the most advanced chip is useful but not universal. So if they can actually do this, they can train it and they can run it at inference time without the latest NVIDIA chips. That's an indicator of some competition for NVIDIA in the data center. That's an indicator that actually some of the edge computing that we've talked a lot about in terms of Apple and Google and what can be run on the phone.
Isn't Apple quite well positioned here?
Well, very well positioned here. And that's a really...
if they can actually make Siri.
Yeah, exactly. If they can make Apple Intelligence useful, then great. But it can be they can be running these kinds of models, and their Apple Silicon is perfectly positioned to actually take advantage of this based on the integrated memory architecture that we've talked about before. Second is that I think that there's potentially more focus on an integrated software stack. So the foundation model may, the advanced companies may be doing more of embedding it in and making it into an integrated stack. So it's more like the Mac OS than Windows, right? Because the problem is that you're not going to get that ROI back if somebody can fast follow. The third is, I think that it really opens up a big pressure and a big focus on product design and development. That if the foundation models aren't where the true competitive advantage is, because somebody can fast follow, then everyone has to think about increasing making human experience
on this, right?
Exactly. You can build products on this. It's a much cheaper model to build a product on. So the question now is, what are the products? Because we've seen some level of innovation there, but so much focus has been at this LLM level. But if that won't be the competitive hold, then people have to really be looking at much stronger innovation and, frankly, doing much more with the products we use every day, which have huge holes in them.
So I think there's another kind of important thing here too, which is just, it sort of highlights just how profoundly uncertain all of this is. And so do you think it's an 8 or a 9 or a 7.5, or just like what happened in Maine, it's a 3.8?
I think, let me see. I think over time we'll see this as something more like a 7-8 kind of a thing. I think right now it feels like a 9, in terms of what it's doing. But I think that it does have, my guess is that it does have some pretty significant, there's some long-term ripple effects from this.
It's certainly broken a few people's mental models, for sure. And lots of discussion about have people being too myopically focused in a particular way. So it's there's that shake-up's the kind of interesting in itself.
Yep. Awesome.
Cool.
Thanks for joining us again. Last bit reminder, don't forget that our Artificiality Summit ticket prices go up at the end of January, so we only have a few days left.
Friday, last day to get a cheap ticket.
Go ahead and use the code that you already have if you've already received an invitation. If you haven't and you'd like to get an invitation, you can fill in a form on the page, artificiality.world/summit. You can send us an email to hello@artificiality.world. You can find us on social places like LinkedIn and Blue Sky. Send us a DM. We're easily reachable. Reach out, say hi, and we'd love for you to join us.
Solid state.